Chemistry is for everybody. Whether or not you know it, you're being affected by chemistry. Science is probably more than two-way street. You have all these different connections. It's really important to the research and work that you're doing. If all this research is trapped inside this bubble, you're not going to be able to impact anybody. But then also, you get engagement on both sides. So not only are you getting the chance to talk about your work with so many different people, get your work out there, get people excited about it, and that leads to funding, of course. But then you also get this inspiration and feedback, and so many great ideas and opportunities come from hearing what other people have to say about your work. I really think that collaboration fosters innovation. So when you're collaborating not just with other scientists, but people in your community, other people in society who aren't familiar with your work, you get these great innovative ideas and opportunities that wouldn't have otherwise happened.
Welcome to the Science with Impact podcast.
My name is Ayanna Lynch. I am an early career professional. Most recently, I work at the American Chemical Society in their outreach department, but I've been working in the science communication and science outreach space for about 5 years. I've always had a passion for bringing research and the people who benefit from research together and facilitating that communication.
What impact has science had on you as a person?
I love science because it's a way to analyze everything, and I really love the scientific method specifically, and so I feel like having a way to break things down, especially chemistry. So my background's in chemistry, and that's all the most is that it breaks things down into their tiniest parts, and I think it's just really transformed the way that I look at everything. I won't even necessarily notice, but people tell me when I'm explaining something or thinking about something, they're like, "Oh, okay, here's the chemist." Of course, science doesn't have all the answers, but it gives you a way to find the answers or think about the answers. When I was younger, that I was going to be necessarily involved in chemistry or a chemist, but I always loved math and science and STEM in general and the problem solving process of it all.
Can you think of an example of you applying your scientific mindset in a way that maybe people wouldn't expect?
So I went camping and I'm not the most outdoorsy person, but I'm trying to get into it. And someone was starting the fire, but some of the sticks around the campfire were looking a little bit damp, but the firewood was dry. So you ended up using the kindling from the firewood as a way to light the fire. And I was thinking about it and I was like, oh, that works so well. And I had mentioned, I was like, I wonder if that's because the combustion point of the logs themselves are closer to what we're actually trying to ignite. And I started talking about lighting Palo Santo and how I've noticed that it's a lot easier to light it from a candle versus a lighter because of the different combustion points. And that was one of those instances where someone was like, oh, yeah, you must be involved in science of some sort. But
I freak out my husband every now and then because I do like experiments on myself and my life and the way
Mhm,
that I process things. I got an Apple Watch and it
mhm,
tracked something called an HRV or heart rate variability. And so I was like,
mhm.
what even is that? And I looked it up and it's exactly what it sounds like. It just measures how much your heart rate varies throughout the day. And it's supposed to be an indication of rest, recovery, stress, athleticism, things like that. But I was tracking mine for the first time and I noticed that it was really low for a long time. And so then I thought, I wonder if other people experience low HRVs. And I looked it up and it's uncommon. What are some of the main modulators of HRV? And so I started doing some research and I narrowed it down to 5 variables and tested each one. And the only one that significantly increased my HRV to a point that was like almost 90% healthy was waking up without an alarm. And like you can literally see my HRV go from an average of like 30 to 50% up to 90 to 100. Like it almost doubled. I wasn't expecting that to be so transformative because the other things were like doing an hour of meditation. I did that for a period of time and it didn't help that much.
That's so interesting. That effect would carry on throughout the day. And I also really relate to that as a scientist with a science background, setting up all these little experiments in life and like almost running a little study on yourself. But the alarm thing is so interesting. I'm gonna have to look into that.
You mentioned all this impact that science has had on you. Was there a moment or a series of moments or experiences that led to you realizing that you could be a scientist and realizing that was a career you wanted to pursue?
As much as I was studying science as a major in college, I never really knew what I wanted to do with it or if I was going to be a quote unquote scientist. But I had this internship, it was my junior year of undergraduate at the Getty Museum. I was part of their Getty NUI internship program. At the time when I was in college, I was a chemistry major and an art history minor. And I wasn't sure how to combine my two passion for these things. And I had this false binary where I thought that pursuing my love of science would be a completely different trajectory than my love of art and my passion for that. At the internship, I had the opportunity to work in their conservation lab, specifically on their microfading tester to see how light affects the conservation and preservation of artwork. And that was just a really great experience because I was able to see the combination of two of my passions and see how chemistry could be applied and so many different aspects. And it didn't have to look like one specific trajectory. It showed me how important chemistry was to the arts and the way that science can uplift all these other different disciplines. And it also gave me a really great opportunity to discuss my work with people who didn't necessarily come from a science background. A lot of the other interns and staff have an art or history background, but I was still able to share all the ways that my work overlapped with theirs. And it was just such a positive experience. And I had a lot of great mentorship there that really encouraged me and showed me that I could work in science and it didn't have to look one specific way.
Do you use the fusion of art and science regularly in what you do?
Sometimes, especially now that there's this STEAM movement happening, that's not necessarily new, but there's been this integration of art and science. And we do have a few different things where art and science overlap. But we have an illustrated poem contest with Chemists Celebrate Earth Week and National Chemistry Week, which is always fun because I get to see people's interpretation of science through art. And a lot of the things that we do are visual. So just having that perspective of how to show people chemistry, I think art always ends up coming back into the fold with that.
What have you found is the most impactful way to show chemistry, at least in your experience?
A lot of my work has been communicating science and STEM and chemistry through hands-on activities. So in my undergraduate activities, I was part of a group called Boundless Brilliance that started as a college chapter that grew into a nonprofit. And we went into different classrooms and gave science demonstrations to the students because we were really inspired by the study that showed that when students were drawing scientists, they often drew one particular figure. It would look like a man. Maybe they drew in their head kind of an Einstein or a Bill Nye. And so we wanted to show them that they could be scientists too. Also through my work here, we do a lot of activity planning and testing. We have an event called Kids Zone where we go out and do these activities with students and being able to break down that wall between what people think science is and showing them and empowering them to be a scientist, even to just that moment. It really helps to show people what science can be, and it doesn't just have to look like sitting behind a lab. You don't just have to be one type of person to be a scientist, and it makes it really accessible to just give people a taste, and whether or not they choose to be a scientist later on, I think it really changes their relationship with science and shows how accessible it can be, that it doesn't have to be.
You do all this outreach work. How do you go about making these engaging and accessible?
It's really about both meeting people where they're at and having, in terms of activities, a really flexible activity for people to engage with in all sorts of ways, which I think also ties into accessibility. One of the things that we consider when we're planning and testing these activities is how many different senses can you engage with this activity and how many different ways can you do this activity or experiment? Are you going to be smelling things, looking at things, feeling things, hearing things even? We just did a great our theme for Chemists Celebrate Earth Week was glaciers, and one of our activities really focused on the sound of glaciers because you have this ice trapped that is escaping as it's melting. I think really just having a multiple different ways to engage in the activities really helps to increase engagement. Being able to do the activity in more than one way, or even having different stations where if you are not really finding yourself excited about this activity, you can do it for a little bit and then pop over to the next one. That really helps with engagement so that people can find out what they like and it gives them a taste of everything and they don't have to feel like discouraged because one thing they didn't necessarily align with.
Is there a way that you all go about measuring the engagement or accessibility of these activities?
So we do a lot of experience surveys. Usually when people are exiting, they'll do an exit survey where we ask a few different questions. But I definitely think that's one of the challenges with doing informal education science outreach is doing long-term measurement of impact. A lot of the activities that we do are for a day or for a couple hours. We want to work more in the future and trying to measure the long-term impact. One of the questions that we ask in our surveys that I really like, it's how do you feel about chemistry? Answer choices range from very boring to like very exciting. I think that is a really easy and approachable way for people to answer how the activity in the program has really impacted them because I think people often have a lot of stereotypes and preconceived notions about what science is. If their response goes from boring to very exciting, I think that shows that they're willing to engage with science the next time they come into contact with it, whether it's a student and they haven't taken a science class before, and now they feel like a science class is more approachable to them, or it's an adult or maybe one of their parents came in with them and they're seeing an article about science in the news. It doesn't have to be some scary thing. They can think about the program that they did and have that to reflect on and think that science is something that they could do and understand as well. It doesn't just have to be somebody talking from really far away talking at them. It can actually be something that they engage in. And that with community science, for example, it's a way to meet people where they're at and make science more approachable. So I definitely think that doing the surveys afterwards is a really great tool to get people's feedback so that we can tailor our activities in the future.
Yeah, that's one thing that I've been working with you and your colleagues over is just trying to figure out how do we measure this? Because we don't get to do long term, at least not yet. And I don't know what response rate we would get if we gave them like an index card with information and then tried to follow up with them if we were able to get their contact information. I just don't know how willing parents would be to sign up for something like that. I imagine only the kids who are really hardcore into science would the parents want to sign up for it. So it's just a tricky thing, but it would be so nice if there would be a way that you could track how many events related to science these individuals are taking their kids to overall and the impact of those as the child matures and makes decisions about their career, whether they choose science or not. Oh gosh, it would just be so interesting. But I imagine the environment that would have to exist for us to track people that closely would probably be a little oppressive. Trying to figure out how to make it measurable without controlling it so severely is a challenge.
Thinking a lot about maybe trying to do more school partnerships because I think that is one way to track the progress over the years and the impact over the years, but it definitely has its challenges. But I'm hoping that I think in the broad look of science as a whole, you can see that the face of science has started to change and become more complex and more diverse as time goes on. So I think these programs are definitely working. It'd be nice if there were a little bit more data and a more consistent way to measure the impact because that will only give more funding to these types of programs and put more force behind them and show that they really are making an impact and show that
What did you think of that index card approach?
when it comes to surveys of making something really short and sweet and also in the moment. And so I love that handing out the index card at that time, it really helped to increase participation in the survey because not everyone wants to go home and sit for an hour and then check their email and then click on it. And I think that really increased getting that immediate feedback. A very simple way to get that feedback from people without being intimidating. It was short, didn't feel like people had to write a paragraph to engage with the survey. I'd love that. I would love to do
Yeah.
things like that in the future.
What is the change that we want to see here? Like with this activity at this event specifically, the students or the participants get maybe 5 to 7 minutes with the activity and the facilitator making slime, right? And so, of course, we could have kids make slime and just have fun with it and just be like, woohoo, we're making slime. And we definitely did that by adding those little additives and you could scent it. But where it got to be not just an activity and turned into a science activity was because your colleague Patty came up with this idea of what if we let them, based on the knowledge that we give them with these bead models and the 3D animation that I made, showing that when you add borate into the polyvinyl alcohol, that it takes these long chains of PVA and it links them, and that's what makes slime all stretchy. So if we could teach them that, we gave them 2 little bottles, and we asked them, "All right, do you want to make slime with more bond breaker or more bond connector?" And they got to, for better or worse, create their own slime consistency. And so the index card for me was just a way of, like, when they initially describe what makes slime stretchy before they do the activity, I imagined that at those ages it would probably be a lot of sensory responses, like it's stretchy or it's sticky or the ways it feels and looks and sounds. But afterwards, my hope was that we would have a conceptual shift into the more abstract things that you can't necessarily see, but now you understand are happening. I think it was like a little over 50% there was a shift there. And for 5 to 7 minutes per person, that's really not bad.
And that's why I love hands-on models and hands-on activities, especially for chemistry, because you have these very abstract concepts that aren't necessarily easy to visualize because we're talking about concepts that are microscopic, atomic level, and you don't really see these things on an everyday basis. So I think having that model and a hands-on sensory experience really helps to make things connect for people when they're learning about these concepts in a really short amount of time. Showing them how it works makes a really long-lasting impact and just really helps to explain these kind of complex topics in a really short amount of time. Chemistry is for everybody. Whether or not you know it, you're being affected by chemistry. Really kept spreading the good word of chemistry to everybody.
What lessons did you learn about effectively engaging young minds in chemistry? But I feel like we've gotten to that. Is there more that you wanted to say about that?
I think, especially when working with kids, their minds are so creative and even bringing their parents into it. People love to ask questions. They are coming with their own perspectives. So being able to just leave that open space for explorations that people can engage in their own way, I think really makes the biggest impact because it's almost impossible to conceive how every single person is going to be able to interact and what they're gonna take away from it, so, I always love a build your own adventure kind of activity. I always think those end up having the most engagement and also gives people a lot of agency to interact and feel like a scientist.
When I do the outreach events and I'll interview participants about what they liked about it, a lot of the times they'll tell us that I really like that you weren't telling us what to do. I really liked that I got to decide and try things and make mistakes. And I asked them, like, is that similar to the way that you learn science in school? And most of the time they'll say no, that it'll be there's a procedure to follow in the lab, or there is instructions that we have to do, or a worksheet that we have to follow. But I understand that in structured educational experiences, they measuring their learning is half the battle there. Whereas inspiring and engaging young people and to think about science and engage with it is really, I think, the battle for informal psychom. So it's just interesting to think about what could liberating students' minds in school do for the impact of science education, and how can we learn from science education a little bit to steal the measurement side of it and integrate that without losing the fun and the magic of it all? It's
I think it's so important to have these informal education opportunities because you have students who really thrive in that really structured environment, and you have students who maybe learn a different way. And I think having a balance of both ends up enhancing the learning experience for everybody at the end of the day because people are able to just experience science and chemistry through these different kind of mechanisms and through that enhance their learning. It doesn't have to be either or, but having a good balance of the two, I think, is really important.
chemistry is pretty abstract. It's a complex topic. In terms of translating that into something that an audience can engage with in a free form way, like we talked about, what are some best practices or frameworks or ideas that you lean on while you do that?
Some of the best practices, especially when doing community work, is tailoring activities or the work that you're trying to convey to the audience that you're speaking to or the community that you're speaking to. I found that the most impactful moments are when people can relate to the chemistry. So, whether you're talking about environmental justice, looking at chemistry from that lens, and helping people to see what the chemistry is in their community. I did a webinar once when I was working at the National Academy of Sciences. This was more similar to science policy in that field. And one of my favorite webinars was about chemistry and food. And one of the reasons I thought that was so impactful and found that there was so much engagement with that is because everybody eats. So having a way to translate the work that you're talking about and the topics that you're discussing through something that people are already familiar with is one of the best practices because people are able to have their own personal relationship. And that just really makes things stick a lot more because, say, you're talking about the chemistry of a local river that you're at. Every time you go down to that river now, you're going to think a little bit more about the chemistry of it. And it's that almost effortless connection that really makes these concepts stick into people's minds. I work on another grant program called the Chemistry Festival Grants. And one of the reasons I love working on that program so much is because since it's international, you see how people are using this funding from the grant program and taking that and really making it their own and relating it to their specific community. And that can look so different all around the world. It doesn't have to be. We're not giving people a strict guideline of the activities that they need to do. They're really just taking their idea, making it their own, and tailoring it to the people that they're trying to reach. I would say that's probably one of my top recommendations, best practices is thinking about the context of where you're at and who you're speaking to and seeing if there's a connection there because I don't know, I'll even go as far as to say 10 times out of 10, there is always going to be some type of personal connection with chemistry or science and the people that you're speaking to.
The outreach activities that I've designed, the one that has had the greatest amount of impact that was measurable was the material science of soccer. And I think a lot of it is there's just so many people who play soccer. I think the majority of us have at least kicked a soccer ball at some point in our lives. And so thinking about what's inside of it and the materials that make it, and then taking that down to the level of the polymers and the chemistry of the structure of the ball, it takes this sort of abstract thing that we often teach using stick figures on two-dimensional paper into, oh, it's what's inside of this battery or this soccer ball or in this river, or it's such a great way to connect people to it so that it's not so abstract. 'Cause with physics, you could throw a ball and talk about Newtonian physics and gravity and vectors, but with chemistry, it can be hard to do that.
I love that soccer ball activity and kind of almost using this like funnel framework, if you will. I think that it's used a little bit with writing, but starting big and narrowing it down is so important with chemistry. Obviously, there's that relationship literally with the chemicals and the bonds and how they have these implications, but starting some with something broad that people already know and have a context and relate to, and then putting them down this path of showing how the chemistry relates to that and showing those connections, I think is where people's minds start to really get started to think more broadly about the chemistry topics.
From your experience coordinating these national outreach events, do you have any advice for research scientists as to how to make their work more impactful through outreach?
Seeing what other local organizations are doing and what kind of organic partnerships with the community you can develop, I think builds a really strong foundation for a great outreach event and long-term partnership. I think going out and seeing what the gaps in the community are and talking to people who are already doing work is really important because lead to some tension if you're coming from your space and not being intentional or being inquisitive about what's already happening there. And I think that also opens up the world of seeing opportunities that you didn't even think of. And I had a great conversation the other day with one of the coordinators who was talking about science outreach in rural areas and how there isn't this intrinsic overlap, but you have people who are working in mining communities or agriculture, for example, and all of those industries use chemistry, and those people aren't necessarily connected to the chemists. And I think that's where the opportunity really lies is going in and seeing what your community is already doing, what are local organizations doing, what are the local schools doing, and seeing how you can be a part of that and build on it and maybe share your ideas with them first. I would say maybe having the intention of not being very one-sided, but really making sure that it's a conversation and an experience that goes both ways because as a scientist, you're learning so much from these people and the questions that they ask, and they're also gaining this insight and learning about their research from you. So I think definitely getting involved and seeing what's already happening and what partnerships already exist and where you can see yourself fitting in is the first step. Not necessarily thinking about the research that you're thinking about, but maybe just thinking about the community and partnerships that are already there and building off of that. There are things that can be built off of or expanded, but there's so much work and really great opportunities happening that can be shared and built upon. So, like you said, you're not just starting from scratch. You're showing up to an empty room. You're talking to people that already have this relationship building. So, getting out and talking to people and like telling people that you're a scientist and wanting to offer these skills. And I think that especially with schools and local organizations, they're always looking for people to come and speak to students, for example. So just sharing about your work and your passions, I think really helps to build those relationships.
I've got a question from a previous guest. So Rakim Marcel came to us and was talking about his role going from academia to industry. He was doing his own consulting thing for a period of time, and now he's supporting another organization. And his question was, so he mentioned the importance of exposing younger generations to a wide range of STEM career paths beyond just doctors and researchers. How do you think scientists and researchers can make their work more accessible and inclusive to diverse audiences, including those with different backgrounds, abilities, and perspectives?
I've been really fascinated with the idea of storytelling in science lately and just being able to, one, exposing younger generations and unrepresented groups to STEM is just sharing your own story. Because I think right now we're at this really interesting point in STEM, the workforce that we have, where there are so many different types of people and so many different journeys that people have had to get to their career. But if you're a kid, you might not necessarily know that you have all these options. And everyone's story is so unique. If we're just focusing on demographics, we miss a facet of their story because you might look exactly the same as me on the outside, but have a completely different journey. And so there's an opportunity to resonate with so many different people by sharing your unique story and sharing all the things that you've been through and all the opportunities that you've had and how you can share that and relate to people on multiple levels, not just demographic, because representation is so important. Representation can look like so many different things. I think that's how you really build a strong community is by bringing all these different people together, especially these days with the internet. I've seen so many great people on YouTube or TikTok or Instagram sharing their stories in really creative ways. And these days you can go in and look up what's the day in the life of someone who's in grad school. And you can find all these different people sharing their stories and see if that's the right path for you and get a taste of it that wasn't necessarily accessible before. Getting creative with how you share your own story is a really great way to expose all these different people, especially the younger generation.
It's funny because we probably think that the day in our lives is the most boring thing in the world because it's what we're used to. And so just inspiring people and letting them know that your voice, your life, your story are interesting.
I think that's what makes it approachable is having it be a day in a life so you can see what your day to day because every day you're not going to necessarily be going and receiving a Nobel
No.
Prize, for example. And so I think it can make it a lot more approachable if you're seeing what the majority of people are doing and what a day to day life and story can look like because science has all these different opportunities. STEM has so many different career paths, and just sharing your story that could be exactly what resonates with one person who is curious about this and wouldn't have necessarily taken those steps otherwise.
What do your day to day look like?
I do a lot of program administration and program management at the American Chemical Society. So a lot of it is calling people, emailing back and forth, working with my team to help facilitate these programs. For example, right now we're in the throes of the Chemistry Olympiad. So we are really excited to welcome our top 20 students to study at the University of Maryland and help them prepare for the International Chemistry Olympiad. And that is a lot of my day to day is planning, thinking about ways that we can improve our programs, analyzing the work that we're already doing and planning for the next one. So a lot of it is administrative, but I do get to have some really fun days where I'm testing activities with Patty in the lab or working with my colleagues to plan National Chemistry Week. Like Robin, she does a lot of that. And so planning those events are a fun way to switch things up, sprinkled in throughout the week.
You got asked a really hard question by Rakim. Now it's your turn to ask your question to the next podcast guest. So, what's one challenge you'd like to ask our next guest about making STEM relevant outside of the lab?
What ways do you think we can evolve our teaching and communication styles? Especially, there's so many rapid changes in technology, rapid changes in just the connection. We're in a very global society now. So, what ideas do you have for evolving our different teaching outreach communication styles moving forward?
Why should our listeners, who are mostly researchers in STEM who are looking to broaden the impact of their work on society, listen to our conversation today?
Science is such a I mean, probably more than two-way street. You have all these different connections, and like you said, societal impact is really important to the research and work that you're doing. And if all this research is trapped inside this bubble, you're not going to be able to impact anybody. And you get to show off one, the fruits of your labor. So we've been talking about ways that you can do that in a way that actually impacts people. But then also you get engagement on both sides. So not only are you getting the chance to talk about your work with so many different people, get your work out there, get people excited about it, and that leads to funding, of course. So we need that side of things, obviously. But then you also get this inspiration and feedback, and so many great ideas and opportunities come from hearing what other people have to say about your work. I really think that collaboration fosters innovation. So when you're collaborating not just with other scientists, but people in your community, other people in society who aren't familiar with your work, you get these great innovative ideas and opportunities that wouldn't have otherwise happened.